Yes. Thanks, guys. Manish and Alvin. I'm getting close. I thought this week would be the week that I remembered every single time. Not so much. Yeah, so we're working in different environments. Once we're kind of done with dev, we're gonna start moving stuff over to QA. So we're gonna push stuff to QA. Well, QA's got their own environment. They've got test systems set up. They've got test databases. They need to refresh those systems for each new project that comes in. So it's a really different environment than development. And then when QA's kind of done with their work and we've quashed all the bugs, now we're going to push to a staging environment probably. And staging typically is a duplicate of the production environment. We're just trying to make sure that everything looks the same as when we're going to push that application right into production. And so the database are the staging machines, like they're going to duplicate the production machines as closely as we can. Same CPUs, same memory configuration, same disk, and so on. I mean, usually staging is a little bit smaller than typical production would be. Like we might not scale it as much. So if the thing takes 8 CPUs, maybe the stage environment only has 4 CPUs. But the idea is that we want to put the application into the environment that it's going to live in production and test it there before we push to prod. So staging environments, again, like, and that's different from production, right? Production's got production servers and production databases and keys and so on. So there's every time we basically move into a new phase of the project, we're going to be faced with configuring the application to work in that environment. I mean, one way to do it is just hard code everything, hard code your connections and passwords and all of that right in your code. But I mean, as you guess, like that's a horrible thing to do. And so instead, we're going to externally configure this stuff so that the application, as it moves from place to place to place, from environment to environment, all we really have to do is apply a new config file so it can read things like, oh, what's my database server? Oh, it's this IP. It's in a config file somewhere. And that it just makes things a little more seamless. And if we write the applications correctly, like you can even write them so that they'll read their configurations on the fly. Like you can send like a sig kill or something. What's a sig kill? Is it 11? Never can remember. Let's do a man page on it. When in doubt, just go to man and kill. What's hang up? Hang up is 1. So a sig 1. If I send a hup to an application and it's been written correctly, I've got a hup handler sitting up there in the application. And hup typically means that hup stands for hang up. Hup usually means I'm going to reread the configuration files. And if your app has been designed to do that, the app doesn't have to stop. You can just let it keep running, update something in the config. Maybe there's an issue in prod, got to switch to a different server. Well, just update the config and send a sig hup over, and it would be a kill 1 and then the process ID. So I mean that's one reason. And by the way, just because it popped into my head about staging environments being similar to prod, very often the staging environment, it's sort of a duplicate of production, right? So same sort of machines, same sorts of configurations, same apps running on those machines, so it simulates production. That's often part of the disaster plan, the continuation plan that most companies have. If something goes wrong in production, like if, God forbid, there's a fire in the data center or a machine goes down hard, those staging machines, because they're similar to prod, I can switch over to the stage machines and keep running the business on those while I figure out how to fix the big problem in production. So all these environments, like they're just really important, and they're all part of the process. There's almost like an environment for each phase, as we go through the projects. So we're going to config stuff. Uh, Another reason for configuration is security. Like a couple of folks have already asked about project stuff, like, oh, we've got API keys now, we've got database keys or whatever. Should I put those up on GitHub? And the answer is hell no. Like, don't put any sorts of keys on GitHub. Just don't do it. The reason is that there are scripts running out there that periodically scan through GitHub, all the projects on GitHub. They scan through them looking for keys, because a lot of these APIs are expensive. Like your stuff, probably not, because I encourage everyone to get free APIs. But let's say, it's a medical database API, that's going to cost me a fortune for that API key, probably on an annual subscription basis or a per request basis. And if I push that key to GitHub, you have to assume that it's been compromised. Somebody's going to have stolen that key, and they're going to either sell the key or use it themselves. It's going to end up incurring cost on your side. So like, we just never, ever, ever push any sort of private key related information up to GitHub. If you do, you just have to assume that it's gone. Actually, it happened to me. I was, what was I working on? It was a project for 412 or something. I was basically pushing stuff up to AWS because I wanted to demonstrate running functions in the cloud asynchronously from another node server, like, calling just a bare function in the cloud. And so I was pushing code up to AWS, and I accidentally included my config folder in my Git repo. And so when I did the push, there, my config stuff was up there. And I kid you not, it was about 90 seconds between the time I hit go. As I was hitting, upload this stuff, I realized, oh shit, the configs are in there. I'll just delete them. So I click go, up it goes. 90 seconds later, I get an email from Amazon. Your developer account has been shut down. And the reason was I had an AWS root key in my config file. They saw it, and it's like, done. They just shut the account completely down. And it was a helpful email. It's like, oh, here's what happened. Here's what we saw. Do these 3 steps to restore your account. It's like, oh, okay, I'll go do this. And it involved, like, I had to rebuild the whole security infrastructure on the AWS side, regenerate keys, redistribute, and so on. So I did those 3 things, and I was dealing with a person at this point at Amazon. Sent him an email. It's like, all done with these. And she's like, great. Now do these 4 things. It's like, oh, okay. So I did these things, sent an email, all done. Great. Now do these 3 things. And it's like, it took about 4 days to get the account completely reconfigured and back online. And all because I pushed a key that I shouldn't have to GitHub. And somebody noticed. Somebody with deep pockets, clearly. All right, so there's some reasons, right? Like, and there's other stuff like our application itself. Maybe we're deploying the application in multiple countries, with different languages and so on. Like, we don't want any of that stuff to be hard coded in the app. You want all the customization stuff needs to be in external files, and then we just apply a configuration rule to say, oh, you're in France, the app's going to be in French. Well, where's the French language? We didn't type it into the app. The French language stuff is in a config file somewhere. We just read them in. So that's kind of where we are. We're trying to abstract out anything that can be configured, stick it into an external file, and then we're going to manage those files. That's kind of the approach. And we'll talk about both of those things in here. We sort of bounce back and forth what I was thinking while I was writing this lecture. We'll start with the localization. Localization is adapting your app to work in multiple languages or locations. There's all sorts of stuff related to locales. So here we're abstracting out the idea of the presentation layer. There used to be, back in the day, if you think about, can you do this, shapes, draw, I can annotate stuff. Annotate, draw, it's draw, I guess. And back in the day, oh, that's sweet, huh? Remember networking? You guys take networking yet? So back in the day, there was a 7-layer stack, right? 3, 6, 3, 3, 4, 6, 7. This is the official OSI. It's like I was looking over to see what was drawing. Business screen. This is kind of the official OSI network stack. So you get the physical layer down at the bottom, which is the wires and so on. And then it goes up through like the data link layer into IP, into TCP, just above TCP in the official like 7-layer network, there was, actually there's a session layer above that, but above the session layer was it was almost like a translation layer. It was called the presentation layer. Presentation. So the presentation layer was all about, it was in here, just above, I can't move anything. It was just above the session layer in the network stack. And the idea here was that any locale-based configuration, so like where you are, would be handled by this layer in the network. Oh, you're in Spain, then everything's going to appear in Spanish. Well, that was still all done by the network stack itself. And if you've had networking, at least had it with me, you'll know that like the OSI 7-layer model, it just wasn't very practical. It was a great model, but it just wasn't practical enough for people to use it. And at the same time, the TCP/IP model came out, the 5-layer model, and the presentation layer and the session layer just went away, which is why things like HTTP are now stateless, because there is no session layer to handle that stuff. And the presentation layer, when that went away, it just meant that the applications themselves had to handle their own configuration. Andrew, networking is 455. 455. I don't teach it very often, just once in a while when somebody's in a bind. Clear all my drawings. Sweet. I love networking. Yeah, let's get rid of that. Cool. So localization is based on something called a locale. So locale is just a set of params, and it looks like this. So it defines where you are and what language you're going to speak. Like around here, we're typically in ENUS or a USEN. And here's a Spanish speaker in the US, will be SPUS, and so on. If you Packet Peeper installed on this? I do. Let's just do like a really quick sort of capture here. Let's see, file, a new cap. And do I want to filter on this? Do I have a filter for this? No, let's do like TCP port 80. So I'm just looking at port 80 stuff. And if I go to any website, let's go to Universal Hub, one of my news sites. Series U Hub. I'll do stop. And clearly the filter was incorrect. File, new capture. Let's capture everything. Let's take the filter out. Cancel. Reload page. File. Really? Where was it capturing not working? So much for that, huh? Let's do view source. I don't think I can see it from here on the network side. Can I see the requests? Request response. I was looking for headers. Screw that. I don't know why Packet Peeper doesn't work. Anyway, what I was looking for was, I probably should just capture it and throw it in the slide at some point. When you, like on a web application, when you do a web request on HTTP, if you look at the headers coming back, those headers are going to, they're going to include information about your locale. I wonder if Postman can do it. Hang on. Postman for the win, right? Everything's slow today. Holy moly. So let's just do like a get on Universal Hub. J there. And if I do a get on this, I just want to see if I can see the headers coming back. Here we go. So here are the headers that came back from that request. And somewhere in here, we should see set cookies, content types. Here we go, content language. So you can see here it's EN, ENUS. So that locale information is transmitted back and forth between the web server and the web client on every request response. And the reasoning is that, let's say on the server side, when I make the request, I can say, hey, here's my browser. It's making a request to the back end. This is the locale I'm interested in, ENUS. And on the server side, like we have access to all of those headers on the server. And so we just pick off that header and see, oh, so what was the locale? Oh, ENUS. I'll build the pages with English for a US audience. You know, if that were SP, MX or something, it's like, oh, we're going to do this one in Spanish and for a Mexican audience instead. So those headers, like normally we think about those in the context of web-based applications, but really any app that's using the network, you can include headers that indicate locale. So locale looks like that. This is all part of something called localization. So the goal here is to create the application so that it can be really just displayed in multiple languages for multiple locales. The act of doing that is called localization. So I'm going to, it's called L10N because there are 10 characters in between the L and the N in localization. And we're just lazy as computer science guys, I guess. So L10N. And that's not new. I've been talking about L10N since the 80s when I worked, or 90s when I worked at Digital. We did tons of L10N. All right, so this is so localization is setting up the application to be able to accept locale-based information, essentially. And for most languages, most frameworks, there's typically a localization package for you to use. Let's say you're in JavaScript, npm. So you're in JavaScript and you need to localize your app. Just go for localization. And there's tons of them. Here's an exact match. That's an old one. Only 39 weekly downloads. Pretty Bytes. Let's see what this one does. Oh, here you go. IET Next. 1.5 million weekly downloads for that package alone. So this is a package that helps us do localization on web applications that are built in JavaScript. There's going to be a similar one for Python, one for Java. All the languages and frameworks have that notion. God, I should look at that. That's a really popular package. High quality, 5-star quality. Sweet. A for maintainability. Oh, that's a great package. So we're going to do localization that way. We're going to apply stuff. Typically, we don't write this stuff ourselves. It's just too tedious. Some examples of L10N. Date formats are different around the world. Most places in the world do day, month, year, or something similar, day, month, year. Here in the US, for some reason, I don't know why, we do month, day, year, which is like just not logical at all. Like there's no reason for that. Times can be different, BC versus BCE and so on. Oh, BCE thing makes me crazy. Colors, like in some cultures, white is pure, but in some cultures, white is for death. It's like you don't want to like build your whole color scheme around like something that is bad, like red, it can mean danger, could also mean luck or passion. It's like you got to figure out like what culture you're talking to and what their style is, like what are their norms. And preferred language, of course. Character flow, left to right versus right to left for some characters. There's all sorts of stuff we have to worry about. Even just formats of numbers, like decimals. Most of the world, in fact, uses a comma, where here in the US we use a period. I'm sorry, it's the other way around. Most of the world uses a comma where we use a, most of the world uses a period, we use a comma. It's just, it's so, I don't know why there are so many different ways to do this. I'm one of those people like just pick one, just pick the logical way, like, calendars, like it's day, month, year. There is no more logical way to do that. Maybe year, month, day, if you want to do it backwards, but just pick that. And then everybody goes with that and you're done. Like there's no translation issues, right? Uh, Things like what does an address look like is different based on where you are. Like we might have all the same information, but it's going to be displayed differently depending on the locale. And then even alphabets, or some are different. Like we had a Swedish guy in class a year or so ago, and he said, "Oh, absolutely, Angstrom is going to go below von Neumann, just because that the A with the little, I don't know what to call it, the little bubble on top, but the little A with the bubble on top, like it alphabetically is a lower precedence than even a V or a W." So all that stuff we got to deal with, right? So that's the localization stuff. Oh, I guess it's internationalization that is setting up for localization. So I18N, there are 18 characters between the I and the closing N here. I18N that's the process of designing the app so it can do localization. I guess it makes sense. So you can remember it by internationalization is the larger word, I18N, so it encompasses more, and localization, L10N, is smaller. That's just the focus on locales. It even has locale in the name. So why don't you remember it that way, Donham? One wonders. And this goes through, like, it shows it here, like internationalization going through right through basically the first three phases. It really is, I think, even more than that, like all the way to the end. And localization, like this localization bit that sort of, is at the end of this process, localization can take a really long time. Like I worked on projects like CUC-Me, our little desktop video app. We intended to distribute that in the US. We were also going to distribute it in France and South America. And so we needed, at a bare minimum, we needed English, French, and Mexican. Sweet. Oh, what do you speak? I speak Mexican. So we needed French and English and Spanish. Well, I think we also translated this one into German for some reason. I think one of the project managers was German. I was like, oh, I want it in German too. So we had like 3 or 4 different languages. We didn't really have the resources in house. We were only a 100-person company. We didn't have resources in house to do all those translations, and so we had to hire out to a firm. And normally the way those are structured is you pay a fee, like an upfront fee for the localization stuff, and then it's a per language fee on top of that. All they do is they set up, the large fee is to set up the system, and then you supply them all the strings that are in your application. It's easy to pull strings out of apps. In fact, there's a string command on the command line to pull strings out. We pulled all the strings out, put them in key value pairs. So like greeting, hello, and then shipped it off to the L10N company or the I18N company, and they did all the translations. And what we got back was a set of files with key value pairs, welcome, hello, welcome, bienvenue, welcome, hola, and so on, for each locale. And then we would pick off the locale value from our user and load the appropriate language files. But the point being that it took time. And even when we got them back, we had to hire another company to proofread them because like we didn't have anyone in house who was fluent in all of these languages. Like we just didn't have anybody who could say, oh, here's what we sent, here's what they sent back, do they match? We needed help with that too. So we had to hire those folks to come in and proofread for us. It took a long time. It took a long time. That was a long running project. We just kept changing stuff on, sort of in the middle of the project. What a mess. Here's what it looks like in Java. So in Java, I don't know why I picked Java for this. I should pick a better language. But in Java, we're going to use resource bundles, and they literally are just key value pairs. So they look sort of. I have one. resource bundles. Yeah, like this. Greeting equals hello. Oops, should have a string around that. But in Java, we can use built-in internationalization stuff within Java itself. So Java is sort of an I-18N language, was built to do this sort of thing. And what we're going to do is we're going to pull things out according to locale. So like here, I'm going to get the locale, and this, kind of looking at the slides, this looks like a JSP sort of application. So JSPs are Java server pages. It's essentially embedded Java objects in a web page, so that within the web browser, I can actually have a connection back to an application server running in a Java environment. I've got Java objects on the front end also, and I can do interaction back and forth that way. It's kind of an old-fashioned kind of way of building apps. You know, Java is kind of a pig, and it doesn't scale all that well for this kind of application, but it certainly works. I wouldn't recommend any of you guys pick Java for your projects. Hope no one did. But if you did, that's fine. Like, you be you, right? Go and enjoy writing Java again. So we just get the locale right off the request. So request.locale, that request is the request object. And then once I've got the locale, so I've got that in LOC here. Now I can use LOC to do things like, oh, give me a date, and then format that date. Like df.format is call the date formatter and format the day based on that locale, so it does the right thing. Same thing with the time. Go and get a time instance and localize it using some configuration file. Number's the same. Like, I won't go through all of these because they're all the same. There are all these resource bundles, and there's an example of one. Using them is pretty easy. Like, this is JSP, so this is an embedded Java application in a web browser. It's going to go grab the message bundle package, which gives me access to these locale files. And again, the same thing, right? I'm on the page, go get the locale, and then within that resource bundle, I'm going to get the correct bundle for the locale. So if I'm in French, I'm going to grab the French message bundle. If I'm in Spanish, I grab the Spanish message bundle. And then once I'm there, I'm just going to refer into them. So messages.getString, messages is this resource bundle. And I can just call a function getString and look for a string with a key matching greeting. The way this works, this %equal thing, you probably have seen this in some of your templating you've done for your projects, that just inserts that into the paragraph, right? So that's going to say welcome or bienvenue or whatever. And then user IDs, like how do we display those? Who knows? Password, username, they're all different in all different languages. Mot de passe. If I'm in the mean backend, most of these things, instead of Java resource bundles in JavaScript, they're just going to go into a JSON file, and we just read the thing during startup. I just talked about that, right? I haven't actually done a localized JavaScript backend application. I haven't done it. I assume, I haven't even tried that. I assume that the JavaScript engine on the backend, like Node, I assume that would respond to like a SIG hop if I needed to change something in a config. If I needed to change like an IP address or database password or something on the fly, I think I can do it without stopping the application by sending a SIG hop. But normally, I'm just going to have config stuff like resource bundles in JSON, and just like the Java version, just read them right out of those resource bundles. And JavaScript is a JSON file. Here's one. I've obfuscated these keys, by the way. Those are not actual keys. Yeah, so like here, I'm down in the app on the JavaScript side, and I've got this JSON file here that has all my config stuff. So I'm just going to read it. Here I call it server params. Go grab server params. It's in config.json. And then I'm going to start setting some stuff. So here I said, oh, you know what? The server params themselves are going to be the server portion of that file, server params.server. So here's the .server stuff in here. Yeah, it's like I've got something here to do server. I don't recall what I was doing that one for. And here I'm using the session secret and so on. So it's just to keep them separate from the app, basically. And then if I'm going to configure a route, for example, this would give me something like on the front end. Let's say on the front end, I needed information like from here, like I needed to know what's the name of the server or what's the IP address. Host could have an IP address in it. So this might be information that the front end might need also. Who am I talking to? Who should I be talking to? So I launch the app, it goes and hits a configuration server, grabs a config, and then continues to configure itself on the front end. So I might just set up a route for it. Here's a route on the back end called /config. Once I'm in there, I'm going to go get server params and return them here. I might have keys. Let's say I'm using public-private keys to encrypt transmissions between the backend and the front end. Well, I need the public key to decrypt those communications. Just stand up a route on the back end that says, oh, get a public key. So all that config stuff can be sent over the network. It's stored safely on the server side. And then I just share with the application side, the browser side, just what it needs. This one is, wow, what crow's going on here? Injectors. This is when the application is actually starting up. So before the app was fully loaded in this case. So I did, this is the config file for the app itself. It's the bootstrap file for the app. So it's first gonna call bootstrap application, which actually starts the application on the JavaScript side on the front end. But first, cut the red wire. It's gonna call fetch data first, and then when that's done, call bootstrap. Here's what fetch data does. It just goes and grabs an HTTP connection. It calls a backend route to get its configs, and then the app.constant says, oh, I'm going to put that in a global variable called config that everybody in the app can use, and then we're done, and I can go and this function error response will now call this guy, bootstrap application. So that is an example of early on configuration for an application as it's starting up. All I really need is enough of the app to grab an HTTP connector and go and call somewhere to get my configs. And then here we use this is really old code, sorry. This is Angular 1. Angular 2 is much simpler. But here was, right there, I'm using them in this line, So I've got a port, I've got a host, and then my connection is going to be to that host on that port. Well, port and host came from the config file that I got from the back end as the app was bootstrapping. We're almost done, Holy Crow. It's going to be a short lecture, guys, sorry. Other stuff, basically anything. The way I approach this is if I've hard-coded something in a file, regardless of what it is, like a string, an IP address, a label, like it doesn't matter. If I've hard-coded something in the application, I'm going to take a really close look at that to make sure that it's not something I shouldn't config. I mean, usually it is something to config, right? So I'll just scan through. It's like, oh yeah, this, and this. Like those are hard-coded. We shouldn't have any hard-coded stuff in the applications in production. So I'm just going to pull those out, throw them into a config file, and just go from there. I might use tokens. So Smarty, for example, is a PHP templating language for you unfortunate folks doing PHP work. So for things like that, those might actually be coming from a database somewhere instead of like a flat JSON file or an XML file. On the back end, at least, I have access to a database. And so if I need stuff like that, well, I need the labels for this locale, I could store those in a database as well and just read them. And in fact, that's probably simpler on the back end than dealing with individual config files. Just put it all in a database when you need it, load it in, right? And then the Java stuff, there's a bunch of Java classes to use. There's a hash table. There's actually a properties class that extends hash table that's pretty good for that sort of thing. Basically, these are they're just POJOs. You guys know what POJOs are? Should use that term on interviews. A POJO is plain old Java object. I guess we could call them a plain old JavaScript object too, although JavaScript doesn't really have objects. POJOs are, sometimes you see POJOs called ADTs. Basically a POJO or an ADT is just an object that just contains key value pairs. There's nothing else in there. So here's an interesting problem that we've got. We're almost done. Here's a really interesting problem. Let's say that the application requires a database on the back end. That database, it's a production database with some pretty secure stuff in it. I need a password to start the database. Like just to start things up, I need a secure password. So the question is like, what do we do with the password? If I stick it in a file and then read that file, I've got a couple of problems. One is that now I've got a file on the file system somewhere that contains a pretty serious secret. Like that doesn't seem like a really great idea. I can't really code it in. I certainly can't code it into the application because now I'm exposing it in the app itself. I have actually seen, my brother-in-law works at Fidelity still. He's in the systems group. And I asked him a year or so ago at one of our holiday parties, like Brian, like, how do you handle this? Because we just talked about in class, like it must have been Easter. Like, how do we handle like this problem of I've got a secure database and I need a password for it. What do you do? And he said, well, we do a couple of things on their side, on the Fidelity side. Sometimes it's kept on a USB key. So the password itself is on a key. He said they're not using biometrics yet to really secure those keys, but the thumb drive itself is stored in a locked place, like a safe. And when you start the application up, you got to go sign in, open the safe, get the key, literally plug it in, start the app, unplug it, go back and log it back in. So that was one way. He said sometimes the passwords are just on paper. Like there's a piece of paper, a single piece of paper with the passwords on it. And an operator has access to those papers. When they start the application, they go and find the correct one. Again, it's in a locked file cabinet, type it in, and then leave. There's just a lot of issues around this. And, I know, it's like, it's a chicken and egg problem. Like, I don't think there's ever been a really good solution for this kind of thing. I mean, just sort of, riffing off the top of my head, it seems like the best solution would be biometric. Well, it's like when I log into my MacBook, I used to use my thumbprint as a thumbprint reader, and it's extremely accurate. iPads too. It seems like I should be able to walk up to a production box and say, hey, I need to start the Oracle database and stick my thumb on it. And that's all I need. Like my thumbprint's been registered as a password essentially. I guess you could still lose that password, but now you're talking like a criminal investigation, right? It's like, oh, where's this thumb? I don't know. Oh my God, the database is running. We can put them on the environment. So when you're starting stuff up, I can do stuff like this. So here I'm starting up a node application, and this -E switch says, hey, stick this information on the environment. I've got this thing called foo that I want to stick on the environment, and its value is bar. And then I have access to process.env.foo inside the application. If you don't know what those are, most machines you can do like a print environment. Not if you can't spell it. So print environment, these all of the key value pairs that are on the process environment. So each process that's running has a set of these. Sometimes it's short, sometimes it's big, and really just any application that needs to store information at runtime about the running process can use the environment to do it. Like here, I've got things like, oh, what's the username? What's the current working directory? What kind of terminal am I on? LC terminal version. What shell am I using? Here's my term. It's an X term, 256 color X term, and so on. X terms came out of digital. Like there's all sorts of information on the environment. And if you need to put something on the environment, it's just an export command. So I could do something like export baz equal bazable or something. And now when I do print environment, let's just look for baz. Now I've got baz equal bazable on the environment. So I could write a script even that would prompt me for a password or a key of some sort, store that in the environment, and then the next thing it would do would be to start the application. So the script itself would ask for the key and then start the app. And then within the app use, like process.env to get to baz, which might be a key for something. There's a couple of ways to handle it. It's just not a real, I mean, the problem with any of these is anytime you type this in, it's going to be sitting in memory somewhere. And if your attacker is adept at sucking down memory from your application, like that's going to be sitting in memory somewhere in your application space. I mean, so that's not the cleanest way either. This just hasn't really been a clean way to handle sensitive configuration information that I've seen. Maybe one of you guys will invent it and that'll be your $1 million idea. All right. God, I remember when I worked at, it was Fidelity doing consulting, I worked on a project where we had to have secure transmissions between Fidelity and a third party out on the West Coast. We were transmitting user information back and forth. And I designed, I don't know why, I designed the security protocol for it. I don't know why they asked me to, because I'm not a security guy. But what we came up with was we had a series of keys. The keys, there were 100 keys generated each month, and we would rotate through the keys. So like on every request, you'd use the next key in line and then wrap around at the top on the 101st request. Well, those keys existed in two places. There were two CDs, like CD disks. There was one at Fidelity. We generated and burned these each month. So one was at Fidelity. The other one went into a briefcase that was handcuffed to a guy's wrist, not kidding. And this dude would get on a Gulfstream and fly to the West Coast with this CD. And there was this little ceremony we came up with to transfer the briefcase over. And so that's how we distributed keys. It was a symmetric key algorithm, duplicate keys on both sides. That's why we had to have two of them. And then it was a physically secure transfer. When you used the application, there was a CD reader. You would take the CD, stick it into the reader, and that's where you read the keys from. So again, they were probably in a buffer somewhere. A sophisticated memory attack would have seen those. But if somebody's attacking you that way, like you've got other problems too. But that was the best thing I could come up with at the time. It's like, I got to distribute these keys. How am I going to do it? This sort of problem. I know, we'll use a Gulfstream and handcuffs was my solution. All right. So, and the bottom line for this, I'm stretching a little bit, sorry. The bottom line for this is just configure everything. If it's a string, if it's an actual configuration item, whatever it happens to be, build the config object for it and then use that config object. And just one more thing. Just pop up WebStorm. Just want to show you one thing quickly. Thank you. Let's see what we've got here. Thank you. I got a lot of projects running apparently. Like here's config, right? So for this application, this is a front end application. For this application, like there's a URL and a key, right? Well, what we do is we don't put that, let's get out the screen. We don't put this folder into Git. So if we're configuring our project to use Git services, this one is in git ignore. Is there a git ignore file in here somewhere? Let's see if I put it in there. Code modules, typings. I just do it this way. So here's git ignore, right? I clearly never pushed this one. We don't want the /config folder in it. Whoops. So what this says is do not push the config folder to GitHub or GitLab or whichever service you're using. It'll just skip it. Same with node modules. That's only because it's enormous. But config, for sure, we don't want that pushed. That's the technique we use. Just put it in git ignore, and then it won't be pushed up to GitHub. It'll still be saved. Like you'll still save, it's just a push sort of thing. You'll still save your configs in Git locally. All right. Way too many projects there. All right, guys. I can't make it go any longer. I tried. Sorry. You can tell jokes for 15 minutes, I guess. So that's it for today. Don't forget, tomorrow is just a day of rest. So just rest tomorrow. On Thursday, we're going to start taking a look at, I've already forgotten what it was. I don't remember what it was. Oh, well, migration strategies, which is more interesting than configs, I think. All right, that's it. Cameron, it was worth coming to class. You now know about the wellness day. That's pretty much the most important part of the lecture. All right, guys, I'll see you later. Enjoy. Enjoy. Well done.